कर लेंगे या फिर you need help? Yes, sir.
No, sir, I will do.
Okay. Hello, hi Alan, how are you? Alan, am I audible? No. I'm not getting any reply from Alan. Also, Saf, I hope you received the timing that the classes are going to be 15 minutes earlier. Did you get that?
Yes, sir, I got.
Alan, are you there? I don't know whether you're in the class or you're not in the class.
Yes, sir.
Yeah. You please try this question. Yes, Saf, your answer is right. Very good. Yeah, very good. Okay. Now, since you have both of you have answered the correct answer, that is C. Let me move on. Regarding solutions, one thing that I would like to repeat is that I will be denoting solvent as A, solute as B, and number of moles as M, mole fraction as chi. Okay, small, I mean, it looks like a small x, but it is chi. Now, solutions can be of three types. And this is on the basis that we are only considering binary solutions. Binary solutions are those solutions which have only two components. Only two components. And most of the chemistry, it deals with liquid solution. That is why we are going to take the solvent as liquid in all of these cases. Okay, so solvent is liquid. The solute can be gas. It can be another liquid, and it can be a solid also. Just as Assalamu alaikum, Hanifa. How are you? Okay, Hanifa, you know that there is a change in timing now. आपको मैसेज मिला था? No,
it's not from 2:30.
No, it's 15 minutes earlier. Okay.
Okay.
2:15 say, okay, because I have to take a break for Maghrib prayer and Iftar. Okay, in between. That is why 15 minutes earlier start hoga. The end timing is going to be the same, that is 6:30. बीच में बस 10-15 minute का कुछ इस तरह का gap होगा. Okay. Now, we are dealing with solutions, and the first thing that we are going to do is the liquid and gas solution. Now, liquid and gas solution is explained by Henry's law, and it states that the partial pressure of the gas inside solution is directly proportional to, first of all, the mole fraction of the solution. Now, this mole fraction zaruri nahi hai mole fraction hi ho. This is basically any concentration. Okay, it is directly proportional to the concentration of gas that is inside the solution. And in order to remove the equalities proportionality sign, we use the constant that is KH. Now, please see, if my solution is having a very high partial pressure, okay, I'm having a very high partial pressure, and I'm taking another solution which has the same mole fraction, but it is having low partial pressure. That means the reason why the partial pressure is increasing is the KH. And that is why if KH increases, what we can say, partial pressure increases. That means KH tells about escaping tendency of gas. If KH is higher, the gases from the solution are going to escape very easily. Because see, agar mole fraction same hai and still the partial pressure is higher for a particular solution, that means KH is higher, and KH is higher than partial pressure is higher. That means KH is telling you about the escaping tendency. And if I talk about escaping tendency, it is just the inverse of solubility. If a gas is very soluble, its escaping tendency will be very low. And if a gas is not soluble, its escaping tendency will be very high. That is why KH is also used to determine or compare the solubility of different gases. So we can write solubility. It is inversely proportional to KH, the Henry's constant. Is everything clear from the liquid and gas solution? Yes or no? Please tell me, guys. Okay, Aksa and Farhat are also here. Okay, Maimuna, Aksa, Farhat. Okay. We announce once again, the class timing has been shifted. It will start 15 minutes earlier. Okay, Aksa, Farhat, Maimuna, those who have joined a bit late. To you guys, it starts at 2:30 normal timing hai. To ab se kitne baje start hoga? 2:15. Okay, and it is going to end at 5 o'clock only. 5 o'clock, no, 5 o'clock, 4 o'clock. It will end at 4 p.m. Am I saying this right? Yes or no? Saif, sahi kar rahe na hum? I have not messed up the timings. Right? Saif?
Yes, sir.
The timings are right, na? Aap log ka 2:30 se 4 tha?
Yes, sir.
So from now it is 2:15 to 4. Okay. So 15 minutes more because I will be having a little break for Iftar and Maghrib. Now, moving on. This is about liquid and gas solution, which is determined and which is explained by Henry's law. Next, we have the solution in which both of the solvent are what? Both of the components are liquid. We have liquid A and we have liquid B. Now, these type of solutions are determined by, these are explained by Raoult's law. Okay, these are explained by Raoult's law. Now, what does Raoult's law say? Raoult's law says that the partial pressure, the pressure that will be experiencing above the solution, it will be due to liquid A and liquid B. Because whenever we make a solution, Some of the particles are always escaping out, and some of the particles from the vapor state, they are coming and they are getting inside the solution. Now, it will depend on the escaping tendency of liquid A and the escaping tendency of liquid B. If the escaping tendency of liquid A is higher, then the P naught A will be higher. That means the vapor pressure of pure A. When the pure liquid A is there, if it is having a higher escaping tendency, it will have a higher P naught A. And if the escaping tendency of B is higher, the P naught B will be higher. And it also depends upon the concentration of A and B. And that is why Raoult's law states that the total pressure above the total vapor pressure that is present above a solution will be equal to P naught A chi A and P naught B chi B. P naught A and P naught B are the pure pressure of the vapor pressure of pure liquid A and pure liquid B. Chi A and chi B are the mole fraction. Now, let us suppose this is the Raoult's law is also the ideal condition. If a particular solution is adhering to the Raoult's law, then it is an ideal condition. Let us suppose here we have some deviation. What kind of deviation can happen? The pressure that we are seeing is greater than the calculated pressure. We can do some experiment. We can put manometer and we can also determine the pressure. एक तो हम लोग calculate करके ला सकते हैं. P naught A का theoretical value होगा, P naught B का theoretical value होगा. The amount of A we have taken and the amount of B we have taken, that is going to give me chi A and chi B. Now, all of these things, we are writing it down. We are not doing any experiment. We are just writing these things down. And then we calculated a particular P. And so this was the expected or the calculated or the theoretical vapor pressure of mixture A and B. Then what we did, we mixed the A and B and then we measured the real pressure. And we found that the real pressure was higher than the calculated pressure. Now, in this case, what would have happened? If the pressure is higher than the calculated one, that means we can say liquid A and B are not interacting effectively. That means we have bad interaction. When we will have bad interaction, liquid A is not interacting, it is not attracting liquid B, then liquid A will be more prone. It will be more prone to the escaping tendency. So kya hoga? It is not attracted by B. That is why liquid A will convert into vapor more easily. Similarly, liquid B will be converted into vapor more easily. Now, the another deviation that can happen is when we have pressure that is lower than the calculated one. That is lower than the calculated one. Now, it will be lower than the calculated one only when A and B are interacting. A and B are interacting very effectively. Now, the interaction between A and B is higher than that of A and B. I hope all of these things must be revising the solutions that you have learned in 12th standard. In this case, what do we have? Here we have good interaction, or rather we can say better interaction. Here we have better interaction. Now, what is the consequences of bad interaction and what is the consequences of better interaction? When we have bad interaction, now, when pressure is increases, we say this is positive deviation. Isko bhi dhyan rakhna hoga, hai? When pressure increases, it is positive deviation from Raoult's law, and this is negative deviation from the Raoult's law. Now, when there is bad interaction, then the delta H of mixing will also be positive, because since A and B are not attracting towards each other, we will have to give some heat or give some energy in order to mix them. And also, when we are going to mix both of them, the delta V of mixing, that means the volume after mixing will be greater than the individual volume. Why? Because A and B do not like each other. They are very far apart. They are repelling each other. So that's why they are taking more space. And that is why the volume mixing will be positive. अब इसके बारे में आप लोग बताइए, है ना? Tell me, what will be the delta H mix for negative deviation? क्या होगा? Positive or negative? Aksa, tell me. Yes, Aksa.
Yes, sir.
What will be the delta H mix for negative deviation? Enthalpy of mixing for negative deviation will be positive or negative or zero? Yes, Aksa, tell me.
Negative.
It will be negative. Why it will be negative? Because when we are mixing it, it is giving me better interaction, and better interaction is going to be exothermic. Similarly, what will be the volume mix, delta V mix? पॉजिटिव और नेगेटिव? मैमूना बताएंगी. मैमूना, टेल मी, द वॉल्यूम मिक्सिंग विल बी पॉजिटिव और नेगेटिव? यस मैमूना. पॉजिटिव होगा. क्यों पॉजिटिव होगा मैमूना? कैन यू एक्सप्लेन इट? मैमूना, कैन यू प्लीज टर्न योर माइक ऑन? ध्यान से समझिए, ठीक है ना? हाँ जी, बताइए. आई कांट हियर यू मैमूना. Okay, Saf, can you please explain what will be the volume mixing?
Negative.
Why it will be negative? Can you explain it?
So when bonds are made, they will decrease a little bit, right? The volume will decrease.
Can anyone explain it in a better way? Aksa? With some better words? No? Aksa, tell me. ऐसे माइक ऑफ करके रहने से कुछ नहीं होगा. हाँ जी, बताइए जल्दी अक्सा. वॉल्यूम मिक्स क्या होगा? यहां से सोचिए, ठीक है ना? देखिए, प्लीज डोंट शट योर ब्रेन्स ऑफ, सिर्फ सुन रहे हैं और फॉर्मूला लिख रहे हैं. बेटर इंटरैक्शन, दैट मीन्स ए और बी के बीच में क्या है? अच्छा इंटरैक्शन है. दे आर अट्रैक्टिंग ईच अदर. समझ में आ रही बात? यस और नो? प्लीज टेल मी ऑल ऑफ यू.
Yes, sir.
What about others? बाकी लोग को समझ में नहीं आ रहा है. Better interaction means attraction. Yes or no? Please tell me. What is the meaning of better interaction? What is the meaning of better interaction? ऐसे चुप रहिएगा आप लोग. रोजा लग रहा है क्या आप लोगों को? जी बताइए. बेटर इंटरेक्शन का क्या मतलब होता है? अट्रैक्शन या फिर रिपल्शन? टेल मी.
Attraction.
सिर्फ सैफी जवाब दे रहे हैं. अक्सा, व्हाट हैपेंड? अक्सा, एलन, फरहत, हनीफा, मैमुना, प्लीज कीप योर माइक ऑन. ऐसे नहीं चलेगा ना काम. यस, कीप योर माइक ऑन. फरहत, Farhat, seems you are not in class, Farhat. Yeah, Alan. What is the meaning of better interaction?
Attraction.
Attraction. जब attraction होगा तो दो चीज नजदीक होंगी या दूर होंगी? They will be near or they will be far apart. Farhat, keep your mic on. Keep your mic on. When there is attraction, the molecules, the A and B particles, they will be near to each other or they will be far away.
Near.
Attraction, near to each other. And if they are near to each other, then they will be occupying less space or more space.
Less space.
If they are acquiring less space, then the volume will be what? Less or more? If they're acquiring less space, then the lesser. And if the final is lesser than the initial, the delta V mix will be negative. If you got this, yes or no, please tell me.
Yes, sir.
What about Maimuna? Maimuna, आपको समझ में आया? Yes or no? You can answer in chat, Maimuna. Okay. Now, the positive deviation, negative deviation हो गया. And one more thing. चलिए. Next thing is boiling point. Okay. Now, what is boiling point? Who can tell me what is boiling point? कौन बताएगा? Aksar, tell me what is boiling point. जल्दी. What is boiling point?
The temperature at which water boils.
अरे वाह. Oh my God. क्या ही definition है? ऐसे define कीजिएगा अक्सा. The temperature at which water boils. What is boil? Boil का क्या मतलब होगा फिर? What's the meaning of boil? Aksar, do humans boil? Yes, Aksar, tell me.
Yes, sir.
Okay, humans also boil. What happens when humans boil? What happens when humans boil? क्या कहते हैं? गुस्सा आ जाता है ना? Okay, when they get angry, they get boiled. Huh? But that is not boiling for water, na? What is boiling point? Farhat, tell me.
The temperature at which the water boils and turns into vapor.
तो फिर evaporation होता है, वो भी boiling है क्या? Because उसमें भी तो vapor बन जाता है ना? Alan, what about you? What is boiling?
So when
What is
a
boiling point?
liquid substance gets converted to gaseous phase.
Then what is the difference between boiling and evaporation?
Okay,
Are you
boiling
good?
is the boiling is
Uh,
at surface level and evaporation is at the maximum temperature.
Evaporation is at maximum temperature.
No, I mean
So
evaporation is at the surface level and boiling is at the maximum temperature.
boiling is at maximum temperature. So, Anifa, tell me, what is boiling point?
When the atmospheric pressure is equal to the vapor pressure.
Okay. So what is boiling point? Please इस definition को all सारे लोग लिख लें. इन लोगों को नहीं पता what is boiling point. Please write. The temperature at which the temperature at which vapor pressure of a liquid, the temperature at which the vapor pressure of a liquid is equal to 1 atm, 1 atmospheric pressure, no, is equal to the atmospheric pressure, yeah, 1 atm is equal to 1 atm, is equal to 1 atm or external pressure, or external pressure, or external pressure. Aksa बताइए, what is the definition of boiling point, Aksa?
The temperature at which the vapor pressure is equal to the atmospheric pressure.
Is equal to atmospheric pressure or the external pressure, है ना? Now, a very good way to remember this is that, let us suppose you have kept a container for boiling and you have covered it, and you're sitting very far away. Now, what will happen to the lid when it starts boiling? The lid is going to start moving, right? And if the lid, how is the lid moving? Because the vapors from the container, inside the container, they're exerting a pressure which is equal to the atmospheric pressure. That is why the movement has started. Now, as soon as the vapor pressure becomes equal to the atmospheric pressure, that time we can see the lid moving, and you can also say directly that the water has started to boil. Okay, so this is the definition for boiling point. Now, tell me, if you have higher pressure, that means if there is a positive deviation from the Rawls law, the vapor pressure is already high. Will it be easier to reach 1 atm or it will be difficult to reach 1 atm? Please listen to the question once again. We already have higher vapor pressure because there is a positive deviation from the Rawls law. We already have higher vapor pressure because of the positive deviation from Rawls law. Now, will it be easier to reach 1 atm or it will be difficult to reach 1 atm? Tell me, guys. The pressure already ज़्यादा है, तो 1 atm, for example, the pressure is here and 1 atm is here. Okay, so pressure is already high. So at that time, it will be easier to reach 1 atm or it will be difficult to reach 1 atm. Tell me. क्या होगा? Aksa, tell me. Yes, Aksa?
Easier to reach.
Easier to reach. If it is easier to reach, if it is easier to reach 1 atm, then the boiling point will decrease, and those type of solution are known as minimum boiling azeotropes. Okay, so which solutions? The solutions that show extreme positive deviation from Rawls law, they show minimum, they are known as minimum boiling azeotrope. याद रहेगा? All of you must have heard these things, right? Yes or no? In 12th standard. हाँ जी बताएं.
Yes, sir.
All of you have heard this, ना? बाकी लोगों ने नहीं सुना है. जवाब नहीं आता, माइक नहीं ऑन होता आप लोगों का इतना. सही है. फरहत, अक्सा, मैमूना, हनीफा, tell me, you have heard these things, right?
Yes,
No.
sir.
When we have negative deviation, the pressure is already very low, so it will be difficult to reach 1 atm. And if it is difficult to reach 1 atm, we will say that the boiling point will increase, and those azeotropes have higher boiling point and also known as maximum boiling azeotropes. Chaliye. So this is everything about the positive deviation, negative deviation. And when you are following the Rawls law, in this case, the delta H mix will be equal to 0. That means there is neither release of energy nor the energy is required, or if there is release of energy, that release is equal to the required energy, and that is why the delta H mix is equal to 0. And the delta V mix will also be 0 in the ideal case. Rawls law ideal case. Vmix is also 0. Now, also remember one more thing, the entropy of this change will be positive. The entropy of this mixing will be positive. Okay, it will not be equal to 0. Now, moving on, liquid plus solid. Now, this concept is also known inside the topic relative lowering of vapor pressure, जो कि qualitative properties में आता, but we are discussing it here itself. Why? We are discussing it here itself because एक pattern बन जाएगा, liquid plus gas, liquid plus liquid, and liquid plus solid. Now, you all know that relative lowering of vapor pressure, it is given by P naught A, that is the pure, this is the vapor pressure of pure A minus P total. P total या फिर P solution लिख देते हैं लोग. I will write P total, that is the total pressure of the solution, upon P naught A is equal to chi B. Now, this term is known as what? Relative lowering of vapor pressure is equal to the mole fraction of solute, is equal to the mole fraction of solute. Now, a note for RLVP is that, see, P naught A minus P total upon P naught A will be equal to, small n is for the mole fraction, small n is for the number of moles of solute. Small n किसके लिए है? Farhat, tell me. Small n is for what? Small n किसके लिए Farhat?
Number of moles.
Of solute या solvent? Solute. So capital N will be for
Solvent.
हाँ सॉल्वेंट. वेरी गुड. ठीक है, ध्यान रखना, ऐसे नहीं कि हम यहाँ पे तकरीर कर रहे हैं और आप लोग का ध्यान कहीं और हो जाए. ओके, सो प्लीज बी फोकस्ड एंड प्लीज listen to everything and concentrate. Now I can also write, I will just flip these fractions. So P naught A upon P naught A minus P total will be equal to small n plus big N. That means number of moles of solute plus number of moles of solvent upon number of moles of solute. Now here we have divided by n, so I will separate small n upon small n, capital N upon capital N upon small n. The small n upon small n will give me 1, capital N upon small n I have written as it is. Now moving on, I can also write, I can bring this 1 towards the left hand side. It will become P naught A upon P naught A minus P total minus 1. Now when I take LCM, I will get P naught A as it is. Now P naught A minus 1 will be minus P naught A, minus P total minus 1 will be equal to plus PT, divided by P naught A minus P total, that is the LCM here. Now P naught A minus P naught A will be cancelled, and I will get PT upon P naught A minus P total will be equal to capital N upon small n. And then I will flip it again and I will get this equation. So this is very important. जब solute या फिर solvent में किसी एक का amount दिया रहे, if you have been given, let us suppose the amount of solvent, and you have to calculate the amount of solute, then in that case this equation is very helpful. Please write this down. This has been derived from relative lowering of vapor pressure only. Please let me know once you're done writing. Also, let me know if you have any doubt in these three. फर्क समझ में आ रहा है आपको?
जी सर.
Okay. Please let me know once you're done writing, or just raise your hand. Just raise your hand once you're done writing this, so that we can move on to questions. है ना? Okay, waiting for Farhat and Saif. Saif जल्दी लिखिए, आपका अभी तक तेज नहीं हुआ है writing speed.
Yes, done.
Done. Okay, चलिए, very good. Farhat, you are done.
Yes, sir.
Okay. चलिए. PA and PB are vapor pressure of pure liquid components A and B respectively. For an ideal binary solution, chi A represents the mole fraction of component A. The total pressure of the solution will be, which option? I'm giving you guys 2 minutes for this. Don't write the question. पहले solve कीजिए सवाल को, उसके बाद note down कर लीजिएगा. Just take a screenshot. Solve करना ज़्यादा ज़रूरी है. Please solve it first. Giving you guys 2 minutes. A small hint. The total pressure is equal to what happens to this? It is equal to PA chi A. Why? Because PA is the vapor pressure of pure liquid component है ना, तो P naught A की जगह PA लिखना है. PA chi A plus PB chi B. Now all the options are having only chi A. That means you have to write the complete thing in terms of A. Let me see. Yes, Alan, correct. Now I can write this down as PA chi A plus PB 1 minus chi A. Why? Because chi A plus chi B is equal to 1. किसी और का आंसर आया? Yes, Hanifa, correct. Very good. Okay. Now you just need to plug in the values. Yes, Farhat, very good, correct. तो यहाँ पे देखिए क्या हो जाएगा. PA chi A plus PB into 1 PB. PB into minus chi A minus PB chi A. Now PB को हम ले आए इधर. Now we have plus में रखना है plus chi A I am taking common. PA minus PB. So the option is D. Please write this down. इस फॉर्मूले को भी लिख लीजिए. Okay, this formula is also important. I mean, important as in you have to remember this formula. It is that important. PT is equal to PB plus chi A into PA minus PB. Here, आप इसको P naught भी कर सकते हैं, just to maintain consistency. Right, next question. The correct option for the value of vapor pressure of a solution at 45 degrees Celsius with benzene to octane and octane होगा in molar ratio 3:2. ठीक है. Take 1 minute to decide होगा या नहीं होगा. Okay, I'm giving you 1 minute. Just एक हिंट दे देते हैं. मोलर रेशियो मतलब क्या हो जाएगा. बेंजीन 3x है, 3x मोल्स प्रेजेंट है, एंड ऑक्टेन जो प्रेजेंट है दैट इज 2x मोल्स. तो chi of benzene will be equal to 3x upon 3x plus 2x that is equal to 3x upon 5x. तो x और x कैंसिल हो गया, काई भी मिल गया आपको. सिमिलरली काई ऑफ ऑक्टेन की आप कैलकुलेट कर सकते हैं. मोल फ्रैक्शन ऑफ बेंजीन कैलकुलेटेड, मोल फ्रैक्शन ऑफ ऑक्टेन कितना हो जाएगा, 2/5 हो जाएगा. ओके, नाउ यू हैव द vapor pressure of pure benzene this much, vapor pressure of pure octane this much. You can apply the formula. या फिर आपको कोई एक भी चीज मिल गया उससे भी आप लोग कैलकुलेट कर सकते हैं. प्लीज कैलकुलेट यूजिंग दिस फॉर्मूला. P नॉट A काई A प्लस P नॉट B काई B. इसको भी यूज कर सकते हैं and it will be better if you use this formula. P total is equal to P नॉट B बेंजीन का ले लीजिए प्लस काई A ये ऑक्टेन का आ जाएगा इनटू P नॉट A माइनस P नॉट B. तो P नॉट B कितना दिया हुआ है बेंजीन का 280 प्लस काई A दैट मींस फॉर ऑक्टेन. ऑक्टेन का कितना है 2/5. व्हाट इज P नॉट A ऑक्टेन का 420 माइनस P नॉट B कितना है 280. कैलकुलेट कर लीजिए इसको कितना आ रहा है. अक्सर समझ में आ रहा है आपको ये सक्सा.
Yes, sir.
थोड़ा फास्ट जा रहा है क्या अक्सा. ये सक्सा इज इट फास्ट.
No, sir.
नहीं ना, ठीक है. ओके, हाँ आइलन करेक्ट, वेरी गुड. देखिए, आई होप ऑल ऑफ यू कैन सी इट इज 280 प्लस, है ना. दैट मीन्स 160 और 168 तो होगा नहीं क्योंकि 280 से ज्यादा है. ओके, इट विल बी आइदर A और D. यस फरहत, वेरी गुड, करेक्ट. चलिए आंसर अब बाकी लोग का निकल जाएगा. इतना जब समझ में आ गया तो कैलकुलेट करना बहुत आसान है. 336 mmHg is the correct answer, that is option D. चलिए मूविंग ऑन. हाँ ये सवाल देखिए, दिस इज इंपॉर्टेंट. इस तरह के सवाल आपके पास बोर्ड्स के एग्जाम में भी आया हुआ होगा, है ना. चलिए आंसर बताइए क्या होगा इसका. द मिक्सचर विच शोज पॉजिटिव डेविएशन. पॉजिटिव डेविएशन क्या मतलब, बैड इंटरेक्शन और गुड इंटरेक्शन. टेल मी गाइस. पॉजिटिव बैड इंटरेक्शन है, तो बताइए बैड इंटरेक्शन किन दोनों के बीच में होगा. Yeah, send your answer in chat. I think somebody said the correct answer. Send your answer in chat. Farhad correct, Aksa correct, very good. Yes, Alan correct, very good. Yes, Hanifa correct. The D option is correct. Why? Because ethanol के पास hydrogen bond होगा and acetone के पास hydrogen bond नहीं होगा, है ना. And that is why acetone will be breaking the hydrogen bonds of ethanol. So it will be bad interaction between both of these. So D is the correct answer. Tell me for the next question. Then for an ideal solution, the correct option is what is the correct option? Yes, Saif correct, very good. Aksa, correct, very good. Yes, Farhad, correct, very good. देखिए नीट में तो आपके पास सिर्फ MCQs आते हैं ना, सिंगल करेक्ट ऑप्शन है, सिंगल करेक्ट. तो डेल्टा H मिक्स इज 0 एट कांस्टेंट टेम्परेचर एंड प्रेशर. डेल्टा H मिक्स पॉजिटिव होता है, डेल्टा G मिक्स नेगेटिव हो जाएगा, एंड डेल्टा V मिक्स भी 0 होता है, बट इन्होंने नॉट इक्वल टू 0 लिखा है. करेक्ट ऑप्शन क्या है? इट इज ओनली A. वंस अगेन, द मिक्सचर दैट फॉर्म्स मैक्सिमम बॉइलिंग एजियोट्रॉप. मैक्सिमम का मतलब क्या? पॉजिटिव और नेगेटिव. टेल मी. मैक्सिमम बॉइलिंग एजियोट्रॉप कहाँ पे होगा? पॉजिटिव डेविएशन या नेगेटिव डेविएशन?
Negative.
किसमें? वंस अगेन सॉरी.
Negative.
नेगेटिव ना? नेगेटिव कहा ना आपने?
Yes.
हाँ, नेगेटिव डेविएशन. नेगेटिव डेविएशन मींस बैड इंटरैक्शन और गुड इंटरैक्शन. बैड इंटरैक्शन और गुड इंटरैक्शन.
Good.
जोर से बोलिए, साफ साफ बोलिए.
Good.
गुड इंटरैक्शन. ना, गुड इंटरैक्शन या फिर बेटर इंटरैक्शन विल बी बिटवीन. देखिए, हियर वी हैव हाइड्रोजन बॉन्डिंग. तो क्या हो जाएगा ये? दिस विल बी आइडियल. ठीक है. हेप्टेन ऑक्टेन, नॉन पोलर अगेन आइडियल. Acetone and carbon disulfide, again both of these are what? Both of these are non-polar, that is why ideal. Now water and nitric acid. Water has hydrogen bonding, nitric acid has what? Ions. तो यहाँ पे interaction क्या हो जाएगा इन दोनों के बीच में? Better interaction. And if they are having better interaction, they will show negative deviation, and that is why they will form maximum boiling azeotrope. So the option will be D. Next, tell me this question. Which one of the following is incorrect? Is incorrect for ideal solution? देखिए, delta H mix is equal to 0. ये तो सही है ना? That means this is not the correct option. Now delta P is equal to P observed minus P calculated by Raoult's law. Now this is true for all the things, whether it is positive deviation, negative deviation, सबके लिए ये equation तो सही है. Okay, so this equation is also right for all of the things. Ideal हो चाहे non ideal हो, दोनों के cases में delta P का definition बस इन लोगों ने दिया है. That is the experimental minus calculated, जो हमने बताया था. Experimental minus calculated. Now delta U mix, when you have H mix is equal to 0 and H mix क्या होता है आपके पास? Is equal to 0. Delta V mix क्या होता है आपके पास? It is also equal to 0. And what is delta U? Delta U का फॉर्मूला क्या होता है? Delta U is delta H minus P delta V. ये तो 0 है, ये भी delta V भी 0 है. That means delta U is also going to be 0. So this is also correct. Now the only option that is remaining which is not correct, delta G mix is not equal to 0. Delta G mix जो होगा, that is negative for ideal solution. That is negative for ideal solution. It is spontaneous. So this is the correct option. बाकी सारे options सही नहीं, मतलब statement सही है, option सही नहीं. चलिए, write this down. Next सवाल देखिए. Theoretical सवाल है. Which of the following statements about the composition of vapor over an ideal 1:1 molar ratio of benzene and toluene correct? We have taken the concentration is same, 1:1. Okay, Assume that the temperature is constant at 25 degrees Celsius. Given the vapor pressure data at 25 degrees Celsius, benzene का है 12.8 kilopascal, toluene का 3.85 kilopascal. अच्छा, ये the vapor will होगा. Tell me which has more escaping tendency, benzene or toluene? According to the question, tell me which has greater escaping tendency, benzene or toluene? कैसे पता करेंगे? Vapor pressure, pure benzene का vapor pressure अगर ज़्यादा है, that means it has higher escaping tendency. That is why it is converting into vapor and increasing the vapor pressure. Okay. So tell me, what is having higher escaping tendency, benzene or toluene? Look at the vapor pressure and tell me which has higher escaping tendency. So I hope you guys are. Benzene has higher escaping tendency, है ना? अगर बेंजीन की escaping tendency ज्यादा है तो बेंजीन का वेपर भी क्या होगा? ज्यादा होगा, yes or no, please tell me. In the mixture, benzene will give more vapor. Why? Because concentration तो same है. Now it all depends on the escaping tendency. Whatever vapor pressure is above the solution, it only depends on the escaping tendency. Why? The concentration is for benzene and toluene is same now. Okay, so we can compare only by using what escaping tendency, that is the vapor pressure of pure benzene and toluene. That means the vapor pressure of benzene will be greater than that of toluene. Now let us look at the option. The vapor will contain equal amounts of benzene and toluene. No, benzene का ज़्यादा होगा. The vapor will contain higher percentage of benzene. Yeah, this is correct. Not enough. ये तो गलत बात है भाई. Information सारा कुछ है यहाँ पे, है ना? Yes, अक्सर C option is correct. The vapor will contain higher percentage of toluene. No, that is wrong. All of you understood this? Yes or no? Please tell me. Mic off करके नहीं रहिएगा, बताइए. ये समझ में आया कि नहीं आया? It's very important. All of you understood this now? Yes or no?
Yes, sir.
Okay, very good. चलिए नेक्स्ट क्वेश्चन देखिए. कितने सवाल कर लिए हम लोगों ने? 1 2 3 4 5 6 7 8. This is 8th question. Tell me which of them is not equal to 0 for an ideal solution? It is not equal to 0. Okay, I'm going to give you guys 2 minutes. आराम से बताइए, इसका आंसर मिल जाना चाहिए. Yes, Hanifa, Farhat, Maimuna, very good. Correct answer. देखिए डेल्टा V मिक्स क्या होता है? आइडियल के लिए 0 होता है. डेल्टा H मिक्स इज आल्सो इक्वल टू 0. Now P observed minus P rolled, that means experimental vapor pressure minus the calculated vapor pressure, both of them are going to be equal in ideal case. This is also 0 because ये दोनों बराबर चीज को माइनस कीजिएगा, you will get 0. Delta S क्या होता है? It is greater than 0. So this is the right option. It is not 0. Okay. Write this down, all of you. Now moving on, colligative properties. Moving towards colligative properties. Now, what colligative properties do we have? We have relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. These are the 4 colligative properties that we have to learn, out of which relative lowering of vapor pressure, we have already seen the formula and everything. Okay, we have already seen the formula and everything. You have the form. Now, elevation in boiling point. What is elevation in boiling point? When we are going to add some solute. And what type of solute? Non-volatile solute. Non-volatile का क्या मतलब होता है? Solid, which is not going to give you any vapor pressure in its pure form. If I keep sugar, sugar is not going to give me any vapor pressure. If I'm going to have salt in its pure form, it is not going to give me any vapor pressure. Okay, वो आज अपने से vapors नहीं बन जाते. It does not evaporate on its own. Okay, so colligative properties are for those types of solute. Now, elevation boiling point means what? When we have a solution, I just have a liquid A now. I just have liquid. Now, when I have only liquid, there will be some vapor pressure. There will be some vapor pressure. Then I added some solid. Now, these solid will acquire some space in the complete solution, and they will also acquire some space on the surface. Now, please remember, they are not only acquiring the space at the surface, they are replacing the solvent molecule and acquiring the surface. They are replacing, they're removing the solvent molecule and then are present at the surface. That means initially when we had 100 molecules of solvent, now we have only 50 and 50 of them are for solid, let us suppose. And that is why the escaping tendency of liquid is going to decrease. And if the escaping tendency of liquid is going to decrease, what will happen to the vapor pressure? It will increase or decrease? Please tell me, guys. कौन बताएगा?
Decrease.
Very good. When the escaping tendency has decreased, the vapor pressure will decrease. And when the vapor pressure will decrease, will it be easier to reach 1 atm or difficult to reach 1 atm? Obviously, if the vapor pressure is lower, it will be difficult to reach 1 atm, and that is why we will require higher than the normal temperature to boil the salt, to boil the solution. Okay, so what we are going to have? We are going to have elevation in boiling point. No, when we have elevation in boiling point, it is given by delta TB. And what is the definition of delta TB? This is not the formula for delta TB. This is just the definition of delta TB. TB means the boiling point of the solution. T naught B means the boiling point of the pure solvent. And the difference between them is the elevation in the boiling point, which is equal to, iska formula ek hota hai chota wala, that is I into KB, that means the boiling point constant into molality. Now, directly molality kabhi diya nahi rahega aapko. What they would have been given, they would give you the mass of solute that has been added in the solution, and they will give you the mass of solvent that is present. Now, mass of solute upon molar mass, that is going to give you the number of moles, divided by the mass of solvent is going to give you what? Molality. And since the WA is in grams, WA is in grams, that is why we are multiplying 100. Okay. Now, again, I hope this formula is not very new to you. You must have seen this for your board examination also. What is this I? I is nothing but the, what is I? Tell me, guys. What is I?
Van der factor.
Fact.
Very good. Van der factor. For example, if I have NaCl, then what is the value of I for NaCl? What is the value of I for NaCl?
2.
2. Achha, for AlCl3, what is the value of I? For AlCl3, what is the value of I?
3.
3. नहीं 4 ना, 3 क्लोरीन और 1 एल्युमिनियम ही तो होगा. ये सुनो, AlCl3 में क्या हो जाएगा? I की वैल्यू 4 हो जाएगी. ये सुनो,
Yes, sir.
है ना, Al and 3Cl negative, right? चलिए, let me rub these things. Similarly, we have depression in freezing point, and the shorter version of formula is I into Kf into M. अच्छा, let us suppose उन्होंने बोला है 50 gram of solute, and they have not told you what is the solute. तब I लेंगे, I नहीं लेंगे, तब फिर क्या यूज करेंगे? Kb into M. Okay, so we'll not use I in that case, जहां पे आपको नहीं बताएगा. But if they're saying NaCl, then you have to put I. If they're saying glucose, for example, now we know that glucose is not going to get dissociated, so I will be equal to how much? I will be equal to only 1. Okay, so please remember these things. ये सारी चीजें जब हम लोग सवाल सॉल्व करेंगे तो वहां पे फिर से आ जाएंगी. Now please write these formula. I hope you are very acquainted with these formula. You can at least write till osmotic pressure. Please write this down. Please let me know once you're done.
Done, sir.
Now, a small point on the molecules which get dissociated and associated, but they don't get completely dissociated or completely associated. They get partially dissociated. We say that those are weak electrolytes. In those cases, wait a second. Before the association and dissociation, note this point down. Colligative property in all of these cases, you must see it is inversely proportional to the molar mass of the solute. Molar mass of the solute is always in the denominator. If you see here we have concentration, which is equal to the number of moles divided by the volume of solution. Number of moles is equal to the mass of solute divided by the molar mass of the solute into the volume of the solution. Again, we have what? Molar mass of the solute in the denominator. That is why colligative property is inversely proportional to the molar mass of the solute. What is this? MB, molar mass of solute. So the ratio of colligative property 1 and colligative property will be equal to the ratio of molar mass of 2 and molar mass of 1. Next, in association and dissociation, we have alpha and beta. Alpha is used when you have dissociation and beta is used when you have association. Alpha is equal to I into -1 upon n minus 1 and beta is equal to I minus 1 upon n minus 1. What is n? N is the number of species in dissociated form. Okay. So for example, अगर हम बात करें NaCl की, you will get Na plus and Cl negative, right? तो यहाँ पे n की वैल्यू क्या हो जाएगी? n की वैल्यू हो जाएगी यहाँ पे is equal to 2. Now let us suppose we have acetic acid or we have benzoic acid in benzene. So benzoic acid, 2 molecules of PHCOOH, they associate with each other as PH carbon double bond O, OH, some hydrogen bond with double bond O, carbon, OH, again hydrogen bond and PH. ठीक है? तो again यहाँ पे भी n की वैल्यू क्या हो जाएगी? N will be again 2. Why? Because number of species in the dissociated form. ये तो associated form हो गया. Dissociated form कौन सा? ये वाला. Okay. So n is equal to the number of species in dissociated form. Please write it down. Colligative property is inversely proportional to molar mass. Please. Please let me know once you're done writing. Okay, everyone done? Yes or no? Is there anyone who is still writing? Saif, लिख लिया आपने?
Yeah, done, sir.
Try this question. The following solution were prepared dissolving 10 gram of glucose in 250 ml of water. 10 gram of urea in 250 ml of water and 10 gram of sucrose in 250 ml of water. The right option for the decrease order of osmotic pressure of these solutions. इन सब में हमने सेम अमाउंट ऑफ सॉल्यूट डाला है, तो ऑस्मोटिक प्रेशर सेम होगा या अलग होगा, किस पे डिपेंड करेगा? टेल मी, कैसे कैसे इसको करेंगे बताइए, हाउ विल यू सॉल्व दिस क्वेश्चन? अक्सा, एनी आइडिया? यस अक्सा, अक्सा टेल मी, नो आइडिया। फरहत, व्हाट अबाउट यू, कैसे अप्रोच करेंगे इसको? यस फरहत, आर यू देयर?
Yes.
जी बताइए कैसे अप्रोच करेंगे इसको? नो आइडिया। देखिए, व्हाट इज द डिफरेंस? ग्लूकोज का मोलर मास अलग होगा, यूरिया का मोलर मास अलग होगा, सुक्रोज का मोलर मास अलग होगा। Now just look at the formula of glucose, sucrose and urea and tell me सबसे least molar mass किसका होगा? Which will have the least molar mass? Tell me guys, which will have the least molar mass? Glucose, urea and sucrose के molecular formula को देख के बताइए which will have the least molecular mass? इतना टाइम नहीं लगना चाहिए भाई। Yes Hanifa, tell me
Urea.
which will have urea will have the least molecular mass. Very good. Urea and then उसके बाद
ग्लूकोज।
है ना, तो यूरिया का प्रेशर सबसे ज्यादा होगा, ऑस्मोटिक प्रेशर, एंड उसके बाद ग्लूकोज। सो यूरिया इज व्हाट, आई थिंक इट इज P2 एंड ग्लूकोज इज P1। P2 इज ग्रेटर देन P1 कहाँ पे है? B। P2 P1 P3। हाँ, नेक्स्ट सवाल लिखो। ऑल ऑफ यू अंडरस्टूड दिस ना? यस और नो, प्लीज टेल मी।
यस
Yes,
सर।
जी
sir.
समझ है ना? ओके, दिमाग खुला रखिए थोड़ा, है ना, इतना बंद करके फॉर्मूला फॉर्मूला मत, रिलेशनशिप्स को भी याद रखा कीजिए। डिप्रेशन इन फ्रीजिंग पॉइंट निकालना, मोलैरिटी वगैरह डायरेक्ट सवाल है बिल्कुल ये, है ना? दिस इज वेरी डायरेक्ट क्वेश्चन। डेल्टा TF इज इक्वल टू KF into molality। Yes, that's correct. Others, please answer, सिर्फ मल्टीप्लाई करना है KF और M को। फ्रीजिंग पॉइंट डिप्रेशन कांस्टेंट मल्टीप्लाइड बाय मोलालिटी, दोनों चीज दी हुई है। इस पर वेरी गुड, करेक्ट। क्या हुआ, बाकी लोग का आंसर नहीं आ रहा है? अक्सा, मैमूना, एलन। अक्सा, टेल मी व्हाट हैपेंड? ये सक्सा, वो जवाब भी नहीं देते हैं बच्चे तो, बिल्कुल क्या ही हो जाते हैं इनको। ये सक्सा, टेल मी। ये सनीफा, करेक्ट, वेरी गुड। बी इज द करेक्ट ऑप्शन भाई। देखिए, दूसरी चीज हम आपको ना अप्रोक्सीमेट करने की सिखाते हैं, ठीक है? देखिए 0.80, 0.60, 0.20, 0.40, ऑल ऑफ दीज आर हैविंग डिफरेंस काफी ज्यादा है सब में, राइट? 4080 एक दूसरे का डबल है, 2040 एक दूसरे का डबल है, 60 इज इन बिटवीन देम। नाउ व्हाट यू नीड टू डू इज अप्रोक्सीमेट कीजिए। इसको आप ले लीजिए 5 और 0.078 को ले लीजिए क्या, 0.08। नाउ मल्टीप्लाई बोथ ऑफ दीज थिंग्स, यू विल गेट व्हाट? 8 5 are 40। और how many decimal points? 1 decimal point, 2 decimal point, because यहाँ पे 2 decimal points है। आंसर क्या आ जाएगा? 0.40। चलिए ये दोनों सवाल कीजिए जल्दी। तो इतना टाइम लगा रहे हैं, बताइए ऐसे कैसे चलेगा? इतना आसान सवाल है। इफ मोलालिटी ऑफ डाइल्यूट solution is doubled, the value of molar depression constant will be? I'm waiting for others. सी होगा ना ऑप्शन, अनचेंज्ड। ये तो कांस्टेंट है। मोलर डिप्रेशन कांस्टेंट इज ऑलवेज अ कांस्टेंट, इट इज नॉट गोइंग टू चेंज विद मोलारिटी। ओके, डेल्टा टीएफ नहीं पूछा उन्होंने, प्लीज रिमेंबर, डेल्टा टीएफ नहीं पूछा है। क्या पूछा है उन्होंने? केएफ पूछा है। केएफ इज अ कांस्टेंट, दैट इज व्हाई इट विल बी सेम। द वैन ऑफ फैक्टर फॉर अ डाइल्यूट aqueous solution of the strong electrolyte barium hydroxide, क्या होगा? बेरियम हाइड्रोक्साइड। फॉर्मूला रहना चाहिए, बेरियम हाइड्रोक्साइड का फॉर्मूला आता, तब आपको पता चलेगा व्हाट इज द वैन ऑफ। अरे भाई बेरियम हाइड्रोक्साइड का फॉर्मूला नहीं आ रहा आप लोगों को? बेरियम में क्या होता है? सॉरी, 3 नहीं होगा, 2 होगा। बेरियम हैज 2 पॉजिटिव चार्ज, OH में 1 नेगेटिव होता है। बैलेंस करने के लिए कितना हो जाएगा? 2। टेल मी व्हाट इज द वैन ऑफ फैक्टर नाउ? यस फरहत, वेरी गुड। ये छोटी छोटी चीजें फिर मार्क्स ले जाएंगी आप लोगों का, देखिए। ठीक है, ध्यान दीजिए। वैन ऑफ फैक्टर क्या होगा? आप तो आंसर कर दीजिए। व्हाट हैपेंड? अक्सा, हनीफा, मैमूना, सैफ, BaOH whole twice. What will be the Van 't Hoff factor? Oh my God. सैफ क्या होगा Van 't Hoff factor बताइए? यस सैफ।
Is it 3, sir?
हाँ थी, तो आंसर कीजिए ना, इतना टाइम क्यों लग रहा है? चलिए आप लोग इस सवाल को सॉल्व कीजिए। एट 100 डिग्री सेल्सियस वेपर प्रेशर ऑफ अ सॉल्यूशन of 6.5 gram solute in 100 gram of water is 732 mm. If Kb is equal to 0.52, the boiling point of this solution will be how much? ठीक है, इसको प्लीज डू दिस क्वेश्चन, हम जब तक नमाज पढ़ के आते हैं। ठीक है, आई विल ऑल्सो शो यू द नेक्स्ट क्वेश्चन। इन दोनों सवालों को करके रखिए जब तक। एक और सवाल दे दें क्या? चलिए, तीनों सवाल ही आसान है, ये तो आपको थोड़ा टाइम लगेगा, बाकी 2 सवाल थ्योरेटिकल है, जल्दी हो जाएगा। ठीक है, प्लीज डू दिस क्वेश्चन, सो आई विल बी बैक इन So guys, are you done? पहला सवाल हुआ किसी से? Alan, Farhat, Hanifa, Maimuna, Saif. Oh, Aksa is not here. What happened? Yes, tell me guys. जी
Yes,
फरहत,
sir.
पहले वाला हुआ नहीं हुआ?
So for the first one, molar mass of solute is not given.
Molar mass of the solute is not given. Okay. So the vapor pressure of a solution is of the solution 6.5 gram of solute in 100 gram of water is 732 mm. फरहत ने किया, फरहत बताएंगी फरहत ने कैसे किया है फरहत? जी फरहत टेल मी. आपने गेस कर दिया ऑप्शन को. ओके. व्हाट अबाउट अदर्स? ये इसको हम बताते हैं. व्हाट अबाउट अदर्स? देखिए, इस सवाल में आपके पास दो चीजें यूज होंगी. एक तो होगा RLVP. RLVP से you will get the number of moles of solute. Okay, what you are going to get? You are going to get number of moles of solute. और फिर उसके बाद यूज कीजिएगा आप क्या? डेल्टा TB. कैसे देखें? At 100 degrees Celsius, the vapor pressure of a solution of 6.5 gram solute in 100 gram water is 732 mm. है ना? Here you have the formula for relative lowering of vapor pressure. इस फॉर्मूले को यूज कीजिए. आगे फॉर्मूला, हाँ, दिस फॉर्मूला. P naught A minus P total upon P total is equal to N upon N. P naught A minus P total upon P total is equal to number of moles of the solute divided by the number of moles of the solvent. ठीक है. अब यहाँ पे बताइए आपको what are the things that you already have here. काम चला गया ये फिर से. यस फरहत टेल मी, इसमें से क्या क्या चीज है आपके पास? P naught है या नहीं है? वेपर प्रेशर ऑफ प्योर सॉल्वेंट. वेपर प्रेशर ऑफ प्योर सॉल्वेंट कितना होता है? एट 100 डिग्री सेल्सियस वाटर का वेपर प्रेशर कितना होगा? व्हाट विल बी द वेपर प्रेशर ऑफ वाटर एट 100 डिग्री सेल्सियस? व्हाट विल बी द एट 100 डिग्री सेल्सियस वाटर बॉईल करेगा, एंड इफ वाटर इज बॉइलिंग एट 100 डिग्री सेल्सियस द वेपर प्रेशर विल बी इक्वल टू 180 m. और अगर हम mm की बात करें देन इट विल बी इक्वल टू 760 mm of Hg. इज दिस राइट? यस और नो? प्लीज टेल मी ऑल ऑफ यू अंडरस्टूड. एलन, फरहत, हनीफा, मैमूना, सबको समझ में आया ये?
Yes, sir.
sir.
P naught A समझ में आया है ना? And what is P total? P total is 732 m. Now this will be equal to P naught A कितना? 760 minus P total is equal to 732 divided by 732 is equal to number of moles of solute नहीं पता, number of moles of solvent 100 gram of water, that means 100 upon 18. तो number of moles of solute कितना आ जाएगा? It will be equal to 100 upon 18 into 760 minus 732 कितना हो जाएगा ये? What will be 760 minus 732? 28 ना? 28 upon 732? Yes or no guys, please tell me. सही है? हाँ या ना? अरे हाँ ना, कुछ तो बताइए, सही है कि नहीं सही है?
Yes, sir.
ठीक है, यहाँ से आपको नंबर ऑफ मोल्स ऑफ सॉल्यूट आ गया। अब इस नंबर ऑफ मोल्स ऑफ सॉल्यूट को क्या कीजिएगा, डेल्टा टीबी इज इक्वल टू, कुछ सॉल्यूट के बारे में बोला नहीं है तो इट विल बी केबी इनटू मोलालिटी। व्हाट इज मोलालिटी? नंबर ऑफ मोल्स ऑफ सॉल्यूट डिवाइडेड बाय मास ऑफ सॉल्वेंट, दैट इज 100, बिकॉज इट इज इन ग्राम, आई विल मल्टीप्लाई बाय 1000, और ये हो जाएगा आपके पास केबी इंटू एनबी इंटू ये 0 और ये 0 कट जाएगी इंटू 10। नंबर ऑफ मोल्स ऑफ सॉल्यूट जो भी निकल के आएगा आपका, उससे 10 मल्टीप्लाई कीजिए, फिर केबी को मल्टीप्लाई कीजिए, यू विल गेट द आंसर। अंडरस्टूड? यस और नो, प्लीज टेल मी। बात समझ में आई? अरे
Yes,
हाँ ना,
sir.
कुछ तो बोले। आंसर आपका आएगा, इसमें कैलकुलेट कीजिएगा तो 101। डेल्टा टीबी जो आएगा ना, दैट विल बी इक्वल टू 1.06 के करीब आएगा। ओके, यू विल गेट डेल्टा टीबी एज 1.06 एनबी कैलकुलेट करने के बाद। तो 1.06 अगर डेल्टा टीबी है, दैट मीन्स द बॉइलिंग पॉइंट ऑफ द सोल्यूशन विल बी, 1 डिग्री आप बढ़ा दीजिए, 101 है ना, तो नियरेस्ट इज 101, सी ऑप्शन। नाउ let us look at the next question. The boiling point of 0.2 moles per kg solution of X in water is greater than the equimolar solution of Y in water. Boiling point किसका ज्यादा है? X का boiling point ज्यादा है Y से। Which one of the following statement is true? X का boiling point ज्यादा, that means colligative property X की ज्यादा। Okay, Saif is saying D. Molecular mass, नहीं उल्टा बोल रहे हैं आप शायद। Colligative property is inversely proportional to molar mass ना? चलिए देखते हैं। अच्छा, another thing please see here, since they are saying 0.2 मोल पर केजी, यानी कि मोलालिटी सेम है, ठीक है, मोलालिटी सेम है, तो अब हम लोग मोलर मास को यूज ही नहीं कर सकते हैं। मोलर मास को यूज कब किया जाएगा? मोलर मास विल बी यूज्ड व्हेन दे हैव गिवन ओनली द मास ऑफ सॉल्यूट एडेड। ठीक है, ध्यान रखिएगा व्हाट दे आर सेइंग। फ्रीजिंग पॉइंट है या क्या है? बॉइलिंग पॉइंट है ना। दे आर सेइंग डेल्टा टीबी क्या होता है? डेल्टा टीबी इज इक्वल टू आई इंटू केबी इंटू एम। डेल्टा टीबी, ये 1 ले लीजिए, ये 2 ले लीजिए, विल बी इक्वल टू ये I1 I2 इंटू केबी तो वाटर का होगा, तो दोनों में सेम, इंटू M1 और M2 दोनों सेम है, दैट मींस द एंड केबी विल आल्सो बी सेम बिकॉज वो दोनों वाटर, तो डिफरेंस कहाँ पे आएगा? I1 और I2 में डिफरेंस आएगा। ओके, प्लीज रिमेंबर दिस। व्हेन दे हैव गिवन मोलालिटी ऑलरेडी, तो वहां पे आप कुछ नहीं बोल सकते। फिर उसके बाद व्हेन दे हैव गिवन मोलालिटी या फिर नंबर ऑफ मोल्स भी दिया हुआ है, तो फिर मोलर मास को नहीं देखेंगे। मोलर मास को कब देखेंगे? मोलर मास विल ओनली बी सीन व्हेन यू हैव मास ऑफ सॉल्यूट एडेड, व्हेन यू हैव मास ऑफ सॉल्यूट एडेड। नाउ वी कैन ओनली टॉक अबाउट I1 एंड I2। तो ऑब्वियसली x का अगर कॉलिगेटिव प्रॉपर्टीज आता है, दैट मींस x इज अंडरगोइंग व्हाट? डिसोसिएशन। x is undergoing dissociation है, हाँ, this is x is undergoing dissociation, C is the correct option. Please write this down. ये दो सवाल बहुत आसान। Which one of the following electrolytes has same value of Van't Hoff factor as that of Al2SO4 whole thrice? Al2SO4 whole thrice में एल्यूमिनियम के 2 निकलेंगे और SO4 के कितने निकलेंगे? 3 निकलेंगे, that means it is equal to 5। 5 और कहाँ पे है? यहाँ पे एल्यूमिनियम 1 and 3, this is 4। K2SO4 में, हाँ, B is correct because you are getting 4 of potassium and 1 will be for this particular complex। K3FnCN6 नहीं होगा, K2SO4 में आपको 3 मिलेगा, तो B is the correct option। Please write this down. B will be the correct option for this। नेक्स्ट क्या है आपके पास? Of the following 0.1 molar aqueous solution, which one will exhibit the largest depression in freezing point? जिसका भी I ज्यादा होगा, because all of these are what? Strong. Because all of these are going to be associated या associated. तो I की वैल्यू KCl में कितनी होगी? 2 हो जाएगी, यहाँ पे कितनी हो जाएगी? 5 हो जाएगी, यहाँ पे हो जाएगी 3, यहाँ पे हो जाएगा 1. तो C is the correct option. Then everyone, yes or no, please tell me.
Yes, sir.
सबने लिख लिया? अब देखिए, मोस्ट ऑलमोस्ट जो भी यहाँ पे आपके पास PYQs थे वो तो हमने करा दिए हैं, ठीक है. व्हाट यू नीड टू डू एज होमवर्क, अब देखिएगा एग्जाम्पलर के MCQs, NCERT एग्जाम्पलर के MCQs जो है किस चैप्टर के? सॉल्यूशंस, ठीक है, उनको कीजिएगा. एग्जाम्पलर के MCQs. ओके, दैट्स इट फॉर टुडे गाइस. थैंक यू वेरी मच. नेक्स्ट क्लास से प्लीज ध्यान रखिएगा, द टाइमिंग ऑफ द क्लास इज 2:50